Sequences are the next thing we'll be talking about in advanced functions. A sequence is an ordered set of numbers whose domain is the set of natural numbers. If you've ever just dealt with patterns of numbers when you were younger, something like 2, 4, 8, 16, 32, where it doubles every time, or maybe 1, 2, 4, 7, 11, 16, where it just adds one more every time, plus 1, plus 2, plus 3, plus 4, and so on. Those are examples of sequences. Sequence is just an ordered set of numbers, or you could say it's a number with a pattern whose domain is the set of natural numbers. So remember, domain is your x values, or it's your input. So what they're saying here is the only thing you're allowed to plug into these is natural numbers. Natural numbers are 1, 2, 3, 4, 5, 6, 7, 8, 9, and so on. So that means no negatives, and that means no fractions or decimals, only positive integers. They do use 0 sometimes, which isn't technically a natural number, but other than that, it's all natural numbers. Now the range, or your output, can be anything. So just because you can't plug in negatives doesn't mean your result might not be negative. Or just because you don't plug in a fraction doesn't mean you might not get back a fraction. So the domain is limited, the range is not. The range can be anything. Okay, notation. Remember, notation just means how we write stuff. So if you see these brackets, these squiggly brackets, I always say they're the Jay Leno brackets because it looks like his profile with a big chin. That represents the entire sequence, the whole thing. Whereas the one without brackets that you see right here, that is just one single term. It's the nth term, or the general term. Okay, so when they write this subscript, and that's what n is, it's a subscript, they're just telling you what term you're talking about. So A1 is the first term, A2 is the second term, A3 is the third term, and so on. So first example of something they might ask you to do is find the first 4 terms of a sequence. So they're just saying, okay, we want to know what this looks like as we get started, so let's plug in the first 4 terms. So it's very simple. You just plug in 1, then 2, then 3, then 4. So if I want to find A1, I just plug in 1 for n, and I get 7. Then I find the second term, I want to plug in 2, and I get 10. Third term, I just plug in 3, and I get 13. Fourth term, I just plug in 4, and I get 16. So my first 4 terms would be 7, 10, 13, and 16. So that's one way to do it. You just literally plug in the numbers 1, 2, 3, and 4 to get the first 4 terms. You can also do this in your calculator. If you look down at B, one way you can do this in your calculator is plug it into y equals. So I have that already plugged in here, negative 1 raised to the x over 3 to the x minus 1. Notice the denominator is in parentheses. That's necessary. I can now go to my table and just plug in 1, 2, 3, 4, which you see I already done here. So those are the first 4 numbers of the sequence. So that's a really simple way to do this if they just ask for certain terms. You can plug it in y equals and then go to your table and plug in the values they ask for. And the good thing here is that if they ask for like the 50th term, you just plug in 50. Or if they ask for the 8th term, you just plug in 8. So it's very easy to find any term you want. Alright, now there are 2 different ways to write sequences. One is the explicit form, which is what these 2 examples are. So these 2 in blue right here, 3n plus 4 and negative 1 to the n over 3 to the n minus 1. These are explicit forms, okay? That's the explicit form. Now the other form is called the recursive form. That's what you're going to see on the next slide or the next page. It uses previous terms to define the current term. So the explicit form, if it just tells you an equation, and if you want to know a certain term, you just plug that number in and you get that term. So if you want to know the 8th term, you plug in 8. The 12th term, you plug in 12, and so on. With the explicit form, you do not have to know any of the terms that come before that one. In other words, if I want to know the 12th term, I don't need to know what the first 11 are. I just plug in 12 and I get my answer. Recursive forms, you have to know the previous terms because basically every term builds on itself. So let's look at this first example. Find the first 4 terms of the recursive sequence. Now recursive sequences are going to start by giving you at least the first term. Sometimes they'll give you more than just the first term. Sometimes they may give you the first 2 or even 3 terms. but they'll always give you at least one. So we start with one term, and then they give you a rule or an equation about what to do to get the rest of the terms. Alright, now I want to try to explain this very carefully. This is a general term, so it represents the term you're looking for. So in other words, we have our first term. What we're looking for next is the second term. So right now, an represents our second term. Well, this right here, an minus 1, now that minus 1 has nothing to do with the value of the term there. It's the index, so it's telling you we want the term before that one. So if n is 2, because we're looking at the second term, then n minus 1 gives you 1, meaning this is the first term. Or if you're looking for the third term, you would plug in the second term. The n minus 1 just means the term right before this one. N minus 2 would mean 2 terms before this one. But the main thing you need to focus on here is what the equation says. The equation says you take your previous term, you multiply by 3, and then add 2. So for this one, we take 5, we multiply it by 3, and then add 2. We get 17. So then to get the third term, we take our new number, 17, we multiply it by 3, and then add 2. That will give us 53. And to get our fourth term, we multiply by 3 and add 2. And that will give us 161. So you just follow the pattern. Multiply by 3, add 2. Multiply by 3, add 2. If we needed the fifth term, we would just multiply this number, 161, by 3, add 2, and that would give us our answer. So a second example here starts with 3. So this is our first term. We need to find 3 more. We need to find a total of 4 terms. We're using the same instructions as before. But this time our rule is that we multiply by 2 and then add 5. So I'm not going to write out the work this time. I'm just going to say, okay, I take 3 and I multiply it by 2. That gives me 6. I add 5. That's 11. Okay, now I use my new number, 11, and I follow the same rule. Multiply it by 2. That gives me 22. Add 5. That gives me 27. Okay, now I take my new number, 27. I multiply it by 2. That's 54. Add 5, and that's 59. So these would be our answers. That'd be the first 4 terms of that recursive sequence. So the key with recursive is they give you the first one, and then they tell you what to do to get the second one. And then you do that same thing to get the third one and the fourth one and so on. Factorials. Factorials are a shortcut way to write multiplication. So 3 factorial means you multiply every number 1 through 3. So 1 times 2 times 3. So 3 factorial is equal to 6. 4 factorial means you multiply every number 1 through 4. 1 times 2 times 3 times 4, which gives you 24. I guess I should say every integer 1 through whatever number that is. So 1 factorial is 1. That should make sense because it's just 1. But 0 factorial is also 1. Now that may not seem to make sense to you, and I understand if that throws you off, but that's really not anything to work out or to understand. That's just the way that the mathematicians have defined a 0 factorial. So you should consider 0 factorial equals 1 to be a definition. Now if you forget this, it's always in your calculator. You can plug that in. In fact, I'm going to show you now how you can plug factorials in your calculator. Okay, so let's just start with the 0 factorial since that one seems odd. So we plug in 0, and then we go to math. And we go over to the right to probability. And the fourth one down is an exclamation point, which represents our factorial. So 0 factorial does in fact equal 1. Our calculator knows it as well. So we can do 4 factorial, so 4, math, go over to probability, fourth one down. 4 factorial is 24, just like we said. Now factorials are super fast. They get super big, super fast. So you put 15, for example, and do 15 factorial, go to math, probability, fourth one down, and you get 1.3 times 10 to the 12th. So that's a 1.3 trillion, if I'm remembering correctly. So just by plugging in 15, the result is 1.3 trillion. This gets big super fast. Your calculator can't even do above like 50 or 60 factorial. If you want to see some more examples with factorial, you can just go to page 929. The only thing you need to worry about for right now is just knowing where that button is in the calculator so that you can use it for your sequences. Okay, now series. A sequence is just a list of numbers. A series is the sum of a sequence. So this area right here I think is the best way I can explain the difference between these two. A sequence is simply a list of numbers. A series adds those numbers together. So a sequence is just a list of numbers. A series adds those numbers together. So let's look down at how we write these series. Okay, the part I have in red, that's the part you're actually going to see. The rest is just explaining the different parts. So this is called sigma notation. Again, this is just how we write series. Sigma is a Greek letter. It's this thing that looks almost like a crooked E or a pointy E or whatever you want to call it. It's a Greek letter, and in math it represents sum, like S-U-M, meaning we're going to be adding things up, adding things together. So sigma, you should always associate with sum, or adding things together. Now, the endpoint, sorry, let me start at the bottom. I is the index of summation. So let me make sure you know where I'm looking. I'm looking right here. So I is the index of summation. You don't need to remember the term index of summation. What you need to know is whatever variable is there, that's your variable for this equation. That's not too big of a deal in our class, but later on you may have times where there's more than one variable, and that's telling you which one you need to plug your numbers into. So then the 1 right next door to it is just your start. It's the first number you're going to plug in. That can be 1, it's often 1 or 0, but it could be another number as well. It can be anything. Now up top, that's our endpoint. It's the last number we plug in. So if you look over here with me, this is a really simple example. I know this page is busy, so I hope this will try to help you focus a little bit. This one goes from 1 to 3, and the equation is 2n. So the fact that it says n equals 1, that n tells me I'm going to be plugging my numbers in to the letter n. So I first plug in 1. So I plug in 1, 2 times 1 is 2. That gives me that part right there. Okay, so 2 times 1 is 2, gives me that. Then I just go up 1, so I go to 2. 2 times 2 is 4, so that gives me that number right there. 2 times 3 is 6, that gives me that number right there. And I stop because 3 is the number I stop at, because it's the one written on top. So then I just do 2 plus 4 plus 6, that gives me 12, and I have my answer. So basically the n equals 1 on the bottom and the 3 on top tell you you're adding up the first 3 terms, the first, second, and third terms. Then you just plug 1, 2, and 3 into 2n, add the results together, and you get 12. Now you can do these in your calculator. So if you look at the bottom, I've shown you how you can do this. Some of the newer calculators have a different way to do this, but the calculator I have here doesn't, so I'm just going to show you this one. So if you go to second stat, so stat is right below delete. You go to second stat, it says list. Then you go over to math. The fifth one down is sum. Then you go back to second stat. You go to OPS. The fifth one down is sequence. So you have sum of the sequence, which if you remember, that is the definition for a series. Sum of the sequence. Then you plug in your equation. So our equation was 2x or 2n. Then you put in a comma. Then you put in x. You're just telling the calculator what variable you're using. So if you'd rather use another letter, you can. Just make sure you're consistent. So if you put 2n, then you have to do comma n. Since I put 2x, I had to put comma x. You have to tell the calculator what variable you're using. Then you tell the calculator where you want to start. In this case, we started at 1. Then you put a comma, and you tell it where you want to stop, which was at 3. So I'm plugging in this equation over here on the right, one from 1 to 3 of 2n. So then I just close my two parentheses, hit enter, and I get my answer. So you do sum of the sequence. And I've got 2 more examples to show you with that. Then we'll wrap this up. Alright, so I need to do the sum, or the sigma notation for n plus 2 from 2 to 5. So the sum of n plus 2 from 2 to 5. So I go to second stat, go over to math. The fifth one down is sum. I go to second stat, go to OPS. Fifth one down is sequence. I put in the equation, x plus 2. comma, x, comma, 2, comma, 5. So again, the pattern is you put in your equation, comma, your variable, comma, your starting point, comma, your stopping point. Close the parentheses. So that one gives me 22. And then the one on the very bottom, second stat, go over to math, fifth one down is sum, second stat, OPS, fifth one down is sequence, and then we plug in the equation. Parentheses, negative 2 raised to the x minus 5, comma x, comma 4, comma 7. So one more time, the pattern is equation, comma, variable, comma, start, comma, stop. Close your parentheses. You get negative 100. So again, we're only plugging in positive numbers, but sometimes our result can be negative numbers for both series and sequences. So 22 and negative 100 would be our examples for this. So sequences are a list of numbers that can be defined explicitly or recursively. Series are the sum of that sequence.